1.4.5 in the chapter Relations and Functions. Let's read it out.
Hi everyone, today we are going to see 10th Standard State Board Syllabus Relations and Functions Exercise 1.4 Problem 4 and 5, and this is video number 10. In this video we are going to see only 4 and 5th problem. Okay? Now we need to know what is onto function before going to the exercise. Now here set A has elements A, B, C, D, and set B, that is a codomain, have elements 1, 2, 3, 4. A has an image 1 in codomain, B has an image 2 in codomain, and C's image is 4 and D's image is 3. Okay? Now what is onto function? We all know A is the domain and B is the codomain. Okay? Okay, what is a codomain? All the elements in this second set is called as codomain. So 1, 2, 3, 4 is all codomain. Okay? Now what is range? There is difference between codomain and range. Okay? All the elements in second set is a codomain, but the collection of images of the elements in the domain is called as range. Okay? Here the codomain is 1, 2, 3, 4 and range is 1, 2, 3, 4 because 1, 2, 3, 4 are all the images of the elements in the domain A, B, C, D. So here the codomain and range is exactly equal and this function is an onto function. Now when I am explaining into function, you will get this clear. Now what are the elements in A here? A, B, C, D, E and B 1, 2, 3, 4, 5. A's image is 1, B's image is 2, C's image is 2, D image is 3, E's image is 5. Now what is a codomain? I have already said all the elements in the second set is codomain. 1, 2, 3, 4, 5. Isn't it? What is range? Range is the collection of images of the domain, elements in the domain. That is 1, 2, 3 and 5 are the images of A, B, C, D, E. Isn't it? 1, 2, 3 and 5 are the images of A, B, C, D, E. 4 is not an image of any element in A. So, 4 will not come under range, but it will come under codomain. So, the codomain and range is not equal here. So, this function is an into function. Clear? Are you following me? Now can you feel the difference of codomain and the range? Okay, now let me explain what is bijection. It's nothing but onto one and onto. Let me explain. Wait, the elements in A are 1, 2, 3, 4. Elements in B are 3, 4, 5, 6. Now, the image of 1 is 3, image of 2 is 5, image of 3 is 4, image of 4 is 6. Now, what is codomain? All the elements in second set, that is 3, 4, 5, 6 and range is 3, 4, 5, 6 because all the 3, 4, 5, 6 are the images of 1, 2, 3, 4, isn't it? So, codomain and is equal to range, so it is an onto function. There is no doubt in it. Right? And if it's a one-to-one function, that is each element in set A have an image in one image in set B. One element, one image. That means it's one-to-one function. So it is both onto and one-to-one function. Then it is a bijection function. Clear? It's both onto and one-to-one function. So both condition is true, then it is bijection function. Clear? Now let's go into the exercise. Here the function is from natural element to natural element. Here the function is defined by f of x is equal to 2x minus 1. We should prove it is we should show that it is one to one but not onto. Okay? Now, what is a natural element? It starts from 1 and it goes like 2, 3, 4, 5 and it goes on. Right? So 1, 2, 3, 4, 5 and it goes on. This is natural element. Okay? Now we have to take the function f of x equal to 2x minus 1 and substitute these natural numbers and find f of 1, f of 2, f of 3, f of 4 and f of 5. Okay? Now what is f of 1? That is the first element of natural element number. 2 into x minus 1. That is 2 into 1 minus 1. Because it is f of 1, isn't it? So 2 into 1 minus 1. 2 minus 1 is equal to 1. Now what is f of 2? 2 into x minus 1. So 2 into 2 minus 1. So 4 minus 1. That is 3. Clear? Now what should we do? F of 3. Very good. 2 into x minus 1. So 2 into 3 minus 1. That is 6 minus 1. That is equal to 5. F of 3 is 5. Next, f of 4. 2 into x minus 1. That is 2 into 4 minus 1. 8 minus 1. That is equal to 7. Clear? Now what should we do? Yes, f of 5. 2 into 5 minus 1. That is 10 minus 1. But is equal to 9. Then it goes on. Okay? Now we have to draw the arrow diagram representation for this to find whether it is an 1-to-1 function and not onto function. Okay? Now, what does the first circle represent? It is x. Both the circles are natural numbers. Okay? Both the circles are natural numbers. The first one is x and second one is f of x. Clear? The first one is x and second one is f of x. Now write the natural numbers 1, 2, 3, 4, 5 and goes on. Okay? Now what is f of x? 1, 2, the same natural number because the function is c, n to n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and it goes on. Clear? It's natural number to natural number. So I am writing the same as f of x. This is the b, ZB. That is a codomain. Okay? Now, when x is equal to 1, what is f of x? When x is equal to 1, what is f of x? We should mark the image of 1. Okay? When x is equal to 1, f of 1 is equal to 1. So, the image of 1 is 1. When x is equal to 2, f of 2 is 3. So, image of 2 is 3. When x is equal to 3, f of 3 is 5. So, image of 3 is 5. When x is equal to 4, f of 4 is 7. Very good. So, the image of 4 is 7. When x is equal to 5, f of x is 9. So, image of 5 is 9. Now, we can clearly see that one element in domain have one image in codomain. See, 1, 1. So, it's 1 to 1. Each element in a domain have one image in the codomain. Okay? You can understand from the name itself, 1 to 1 function. One element in domain, one image in codomain. 1 to 1. Okay? So, it's an 1 to 1 function. Okay? Now, we should prove whether it is an onto or not. Okay? Do you remember what I said earlier about onto function? Can you recall? We have to find the codomain and range. Now can you remember? Yes. What is codomain? The entire second set. 1, 2, 3, 4, 5, 6, 7, 8, 9 and it goes on. This is codomain. What is range? Range is the collection of images of the elements in domain. What are the images of the elements in domain? 1, 3, 5, 7, 9 and it goes on. Okay. Here 2, 4, 6, 8 are not the images of x. Right. So we can say that the codomain is not equal to range. Okay. The codomain is not equal to range. Isn't it? So what does it mean? It is not an onto function. It is not an onto function. When codomain is not equal to range, it is not an onto function. It is an into function. Okay? So, in this problem, we have found the natural numbers, substituted natural numbers in f of x and found the images of the x. We have drawn an arrow diagram to represent the range images of the domain elements and found that it is one-to-one function because each element in domain had one image in the codomain. So it is one-to-one function, but the codomain is not equal to range because in the codomain 2, 4, 6, 8 are not the images of domain. So it is not an onto function. Clear? Okay. Now let's go to the fifth question. Here too the function is from natural to natural number. It is defined by, the set is defined by f of m is equal to m squared plus m plus 3. We should prove it is an one-to-one function. Now what is a domain? That is A or N. Natural number starts with 1, isn't it? So 1, 2, 3, 4, 5 and it goes on. Clear? Now we have to substitute these values of 1, 2, 3, 4, 5 and find the images of these domain elements. Now take the function m squared plus m plus 3. F of 1 is equal to 1 squared plus 1 plus 3. 1 squared is 1, 1 plus 1 plus 3 is 5. Clear? That is 5. Now next one is f of 2, isn't it? So m squared plus m plus 3, therefore 2 squared plus 2 plus 3. That is 4 plus 5. 2 squared is 4 plus 5 which is equal to 9. Clear? Now f of 3, isn't it? M squared plus m plus 3, therefore 3 squared plus 3 plus 3. What is 3 squared? 9. 3 plus 3 is 6. So 9 plus 6 which is equal to 15. Clear? Okay. Now let's go to the f of 4, isn't it? We can substitute 4 as m. M squared plus m plus 3, therefore 4 squared plus 4 plus 3. What is 4 squared? 16. 16 plus 4 plus 3? 7. That is equal to 23. Next, we have found f of 1, f of 2, f of 3, f of 4 and it goes on, it continues. Now we have to draw the arrow diagram for the domain and codomain and show that it is one-to-one function because that is a question, right? So what is the domain? X. What is the codomain? F of x. Okay? Okay. Now we can write the domain. What is the elements of the domain? 1, 2, 3, 4, 5 and it goes on because both are natural numbers. Right? So we should write 1, 2, 3, 4, 5 and it goes on. Okay? So I am writing 1, 2, 3, 4, 5 and etc. because it is a natural number. Now what is f of x? It is also a natural number. So I am writing 1, 2, 3 and goes on till 5. Then I am writing 9, 15, 16, 23, 24 and it goes on. Why I am writing particularly these numbers are because they are the images of the domain elements. Okay? Now we are going to draw the arrow diagram. If x is equal to 1, f of x is equal to 5. So the image of 1 is 5. Right? When x is equal to 2, f of x is equal to 9. Then the image of 2 is 9. Okay? When x is equal to 3, f of x is equal to 15. So image of 3 is 15. When x is equal to 4, f of x is equal to 23. So image of 4 is 23. On seeing this arrow diagram, what can you say regarding one-to-one function or many-to-one function? It is one-to-one function, isn't it? Because each element in the domain have only one image in the codomain, isn't it? It can be clearly said from the name. It can be clearly said from the name one-to-one function. One element domain, one image in the codomain. Okay? So, here this is clearly an one-to-one function. So, in this question, we have found the natural numbers and we have substituted the natural numbers in f of m and found the images of those numbers and we have drawn the arrow diagram and we can clearly see that each element in the domain have only one image in the codomain. So this function is absolutely and one-to-one function. Clear? So with this, exercise 1.4 problems 4 and 5 is over. We can see the remaining sums in the next video. If you have any doubt, comment down and I will clear it for you. I have given the link of the playlist in the description box. Please make use of it. Whenever you get free time, practice maths. Meet you all in the next video. Till then, signing off, Padvina Ramesh. Bye-bye.
Subscribe, hit the bell, leave a like.